All right, your boy Chili here. Welcome back. I am messing around with shared memory in Windows. If you don't know what's going on, then you didn't watch the first part of this, mini series, and that's on you. I ain't gonna freaking explain that stuff again. That took 20 minutes. So let's play around. Let's create some named shared memory. So I just got like a whatchamacallit, like a console application in here. And we're going to use this to test out our shared memory. It's going to be communication between two processes, basically a server and a client. I don't want to write two Visual Studio solutions, one for server and client. So we'll just do them both in the same program. We can do that. We can just, when we start the program, we'll just determine if we're in server mode or in client mode. So int argc. I never use this stuff, so I don't remember what the signature is, but I think it's int argc and then car pointer to argv maybe. I don't know. P args. I like that better. So it's a pointer to an array of C strings, basically. Okay. Now, let's say if... so we got to make sure we have the right number. The first thing in the pargs is going to be just the name of the program. And then after that, you have the different tokens from the command line. So we want to see if it's greater than 1. And I'm just going to use std string. I'm not going to use the C style functions because screw them. So std string, we're going to create a string from pargs. The first argument, that's not the file name. If that is equal to serve me daddy, then we are in server mode. So std cout server mode enabled. Otherwise, cout like that. All right, so this is how we'll differentiate. This is basically how we will, I won't say fork, but you get the idea. It's going to be one or it's going to be the other. And if you don't return 0 from your main, you're a savage. And not the good kind of savage. Not the Jake Paul kind of savage, if you know what I'm saying. All right, so now if we run this, see if it crashes. Yeah, so if we do nothing, client mode, it'll run in client mode. But if we pass it the secret code on the command line, it'll run in server mode. Yeah. There we go. Now, this is a cool extension for Visual Studio. It allows you to manage your command line arguments for the debugger. So we'll put one in here, serve me daddy. And you can have like a whole list of them, and then you can turn them on, you can turn them off. Yeah. So now if I run this, yeah. So now we can turn this off and on. We can run in both modes. I don't believe we can run, let me try it. I don't believe that Visual Studio lets you like run multiple instances of the same thing. Yeah, it just brings up the already existing instance, which kind of sucks. Maybe if we run it without debugging? I don't think it does. No, it just brings up the existing one. So I'll have to open a terminal window for the other one. Where's the showing open file? Yeah, that's what it is. That's the one. And then I will go maybe, where is it? In here? Yeah, and then I'll go PowerShell. And then I don't trust PowerShell, so I'll go command. And then I can run mems.exe. I just run mems. Yeah, there you go. And then if I run mems with you go. Okay, so beautiful. So we'll be able to run two processes at once in different modes, server and client, and beautiful things will happen. Okay, so let's do some programming. All right, so what do I want to test? I mean, I want to try to just get shared memory working, basically, in any capacity. But I also want to try to basically prove my hypotheses that I can't map into an existing, like I can't map to some memory location on a heap. I can't create a vector and then try to map my shared memory into that vector to expose it to another process. There's no way that works, but I want to prove it because I'm just like, I believe that it won't work, but I have no idea. Now here's the thing. So the two things you do is you create the file mapping, and that will create, those pages here, but then you have to map those into each process that wants to use them. And you do that by calling map view of file. So map view of file will take a file mapping object and some flags and stuff, and yeah, it'll map it into some place in your virtual memory space. The place that it maps into is the return value. So it will tell you where it got mapped into. So the operating system chooses where it goes. It'll choose a likely place. But there's also map view of file EX plus alpha, which allows you to specify, the micromanage it and specify, okay, I want you to put that stuff, I want you to map that stuff right here. So you can point to a place in your virtual memory space and tell the operating system it better damn well map that shared thing into where you told it to. Otherwise, there's going to be trouble. The return value, yeah. The function succeeds if the memory is not already in use by the calling process. So this tells me, yeah, it's not going to work. But let's try it anyways. I mean, what the hell? I got to fill air here. I got to make videos. This is like the filler. Now, here's the thing. You can't just specify any old address. It's got to be a multiple. It's got to be a multiple of system memory allocation granularity, which is basically, I believe, the pages that I talked about, the size of a page. And that's because it's got to map, integral page. It can't map half a page to some player. It's got to map whole pages. So the base address has to start at a page granularity, if that makes sense. So we can get that information with get system info. Wait, I don't want to get rid. I want to keep this. I want to open that. There we go. So let's do that. Let's just explore here. Get system info. That seems like a good one. We're going to include the omega header windows.h. Close. That was close. Now get system info. Yeah, LP system info. So I guess system info. Haha. There we go. Don't do that. And info. Just to be sure, in case there's some problems. You don't return HR? You return nothing. Okay. Cannot fail. Maybe. I don't know. I don't know what's in this structure, but we'll let our debugger tell us that. Let's just do it. Let's just try it out. Okay. Do I have... Yes. Yes. Yes, queen. Okay. So... info. It is filled with garbage. It has been zeroed out. And give me that good stuff. Okay. I was afraid this would happen. We need Just something to step to before we exit the scope. Anything will do. All right, we're back in business. So, info. Okay, so the page size was actually 4 kilobytes, not 1 kilobyte. I was only off by a factor of 4. Pretty good. I mean, on a logarithm scale, that's not too bad, right? Anyways, so number of processors, yeah, that's correct. W processor, I don't know what many of these things mean, but I know what some of these things mean. I certainly know that this is the page size, 4096. So any address that we give to the mapping function has to be a multiple of this number. Cool beans. And actually, you know, I'm just gonna change my mind. I'm just gonna let this chill out here. It's gonna chillax into the memory. Okay. So now, first thing we got to do is before we map anything into anywhere, we got to create the shared memory region, the pages that will be mapped. So give me that sweet MSDN. I don't know what it's called now. docs.microsoft.com. MSDN was a cooler name. Don't at me. Create file mapping A. It's Canadian. This function is Canadian. So I'm just going to move this onto my other monitor for reference sake. And let's just go. Constant auto h result is equal to create file mapping to A. There's a NUMA. There's a NUMA A, a NUMA W, a W. Man, there's so many options. Create file mapping A. by. Okay, so H file, we know this one. It's got to be invalid file. What? Invalid handle value. I was wrong. Handle value. There we go. And that's to tell it, no, we're not going to be mapping a file on the file system. Just going to be mapping some memory, and you can back it up into the swap if you need to. Security attributes. So that is a pointer to a structure. We don't care. We're not going to worry about security right now. We're just messing around. Famous last words. What's next? No, I didn't. Whatever. Don't stop messing with my formatting, dog. Okay. Now the next one is protection. So what kind of protection are we going to put on this region? And I'm just going to say, yeah, we can allow you to read and write from here for now. But you could make it so that it's only executable or only read. And then anyone who maps into it are only allowed to specify that kind of thing. But anyways, that's neither here nor there. Maximum size. So maximum size is funny. It's 64-bit value, but it's split up into two 32 bits. So the high 32 bits is 0. We're not going to allocate over 4 gigabytes. The low is going to be, let's see, how much memory do we want to allocate? And let's allocate like a single page worth, which is going to be info.dw page size. There you go. And finally, we give it a name. We give a name to, because it's a create file mapping. It's a named file mapping. I guess you could create an unnamed one. And then it would have to be some kind of handle. But I like names because it seems easier. So, I don't know, const expr const car pointer to name is equal to. Now this is interesting. This is a thing that I know from experience. You can put the names in either starting with local / or global. But if you do global, then you need to be like administrator level. So that's annoying. So just do local. And we'll call it Chili share. The share zone by Chili. share zone. I like that one better now. Okay. And then we'll just put name in here. And there you go. If this were create file mapping W, this would have to be a wide string. And Bob is your uncle. So this will maybe create the file mapping. Seems plausible. Let's see what kind of HR Geiger we get out of this bad boy. Add item to watch. I wonder if I could just add this to the watch. Can I drag that? How do I add this to the watch? What if I drag it? Do you hear? He did it! The madman. HR. Can I rename it? Edit. No, I don't want to edit it. Yeah, there we go. Comma. No. You had it so good. Comma HR. So this tells it this is a Windows error value, and it's going to do some cool stuff. Cool tricks with the debugger. So, create file mapping. Wait. Sigh. There. Please understand. Go. There we go. C4. Wait. Type void pointer to const. Okay, I was wrong. Again. Was I wrong? This returns a handle. This returns a handle, not an HR. I'm dumb. Shared handle. Okay. Now, if I did it, here's how. If shared is equal to 0, maybe? What is shared handle? What is a handle? What is a man? A miserable pile of secrets. We can do that, right? Yeah. So if that is null, then that means that there was an error. It's equal to get last error. There. Okay. Error handling. Whoa, beautiful. Adds an additional, like, at least 20% to the length of the video. And that's money in the bank. Okay, but it wasn't 0, right? So we in there, dog. Yeah, no error. So that worked. We created our thing. No surprises nobody, hopefully. Now, if you create a shared handle before you go to bed, you should probably, close handle, shared. Okay. Maybe I'm dumb. Are you happy now? I was like, why is my IntelliSense sucking? And I was like, oh no, wait, I'm just dumb. Okay, that works. We create the handle, we close the handle. Does this give it gives a bool. Is the bool, I can never remember if it's typically truthy for a failure or falsy. I feel like in Windows sometimes it's truthy and sometimes it's falsy. They don't have much of a consistency. Great. File mapping. Is it going to give me a link to close? Close. Handle. There you go. You beautiful bastard. return value, if it succeeds, the return value is non-zero. Okay, so non-zero for success. But HR is 0 for success, just because. I think it's 0. It might be non-zero. I don't know. You know what? If it's not equal to 0, no, it's non-zero for success. So if it's equal to 0, then, yeah. Then we do this. All right. Okay. Hit me with your best shot. Let's do this. All right. We create this. We get a handle. We close the handle, and we're done. All right. So we got a handle. We close the handle. Whoopie-de-doo, it doesn't actually do anything. There's no words on it. But now we could try to map that into memory. So what I want to do, let me think here. I want to map this into a place in memory. So I'm going to create a vector. So the test is, for those of you who have, forgotten the whole point of this bullshit that I started 5 years ago, we want to create a vector. Why are my speakers making such noise? Shut up, bro. Stop buzzing. Anyways. Buffer. Well, I gotta get rid of this buzz. It's fucking killing me. All right, I think I fixed it. Anyways. Okay, so we'll create a buffer. Now, I can never remember, like, what's the constructor? Like, if I do a constructor like this, no. What's the one that lets me specify the size? Dogman? I don't know. Let's just do, like, info dot page size times 4. So 4 times the page size. So that's lots of space. And we just want to map, like, a subsection of this buffer that is aligned to the page boundary size thing. So there's got to be one in here that's like, give me n things, the value of which is 420. That doesn't fit into car. 42. Okay. So it's going to fill a bunch of memory with the value 42 for each byte in that memory. Now, here's the tricky part. It's not that tricky, is it? We get the address of the beginning of this buffer. So, auto p is equal to buffer dot data. Yeah, that's the ticket. Then, so like, so we don't know, let's say this is our vector now, we want to share out. It exists on the heap, as they tend to do. But like, its start address is probably not going to be aligned to the start, of a page boundary, right? It's not going to be a multiple of 4096. So like, if we were to take whatever this address was, adder, and we were to do mod 4096, we would get the distance from the page boundary to the left, which is outside of the vector. And then if we were to add that to ADDR, if we were to subtract that from Q is equal to the address. Just hold on a second. Hold on a second. Everybody calm down. We subtract that mod from that, and then we will get the address of the page to the left. And then we add 4096, and then we will get this, the start of the first page that is inside the vector. Okay? Okay, everybody? Are you happy now? There might be like a better way to do that, but this is fine. This is fine. This will work. Yeah. I mean, there's ways you could do it. Like if you did bitwise. I might do this now that I've thought about it, that I've taken the effort. But if we do like bitwise negate, not complement of 4096 minus 1 and ADDR, that will give us this. Yeah. You know what? I like this one better. It doesn't matter which way you do it. Anyways. So I don't know if we can do modulus on these things. We might have to do some casting bull poops. But anyways, so what did I say again? Address minus address. So P, let's do auto P buffer. That's the wrong place for that. P page is equal to P God damn it. Buffer modded info dot page size. Yeah, there's no way it likes that. It doesn't like that arithmetic whatsoever. And I'm on board. I agree with you, compiler, but we're doing some weird stuff here. You're gonna have to get on the same page with me. So P buffer minus this plus 4090, no wait, plus info.dw page size. There you go. All right, now, there's no way it's gonna, yeah, expression must have integral. Okay. All right, everybody calm down. Okay, so we need to cast this. There's lots of different ways we could cast this. The way that I choose, so there's like a type that is specifically meant for casting pointers to an integral type. That's like the fancy way to do it. I could just cast it to like an unsigned long and it'd probably work. Okay, here's the deal. Include cstdint reinterpret cast std uint pointer t. Unsigned int, that's the size of a pointer thing. Yes. Now, mod that. That will give us a number of bytes. Subtract that from this one to go back that many bytes because type is car. Then add a page size, and we're good to go. There's no way that this can't work. 100% confidence. 150% confidence.